All right, this is page 44. What we did yesterday is the very first few steps to what we're doing today. And what we're doing today is very important. First of all, for Unit 4. Second of all, for a specific unit in geometry. Third of all throughout Algebra 2. Okay? So when am I ever going to use this? This topic is heavy throughout future math classes. And if you go past Algebra 2, when you get to college classes, no matter what you major in, you have to have at least 1 or 2 math classes. You have to know how to factor. I teach the college math classes. When kids come to me and they can't factor, they are the ones that get the most, they feel the most defeated, I guess you could say, because you should be able to factor before you get to the college math class, okay? So I'm going to show you how to factor. We're going to use what's called the box method. The box method is what's helpful for organizing your work. If I feel like you are getting it, you understand it, you have no problem with organizing your work, I'll be glad to show you another method that is less writing. But I need to be able to trust that, you understand the math, you know how to do it. I'm not showing the shortcut method to everyone because this is the foundational principle, you know what I mean? You got to know the hard way before you can know the shortcut way. Because I think it'll just confuse you. All right. If you recall from yesterday, we're taking a trinomial, and the goal is to get it down to, you don't have to write that yet, but the goal is to get it down to a binomial times a binomial, right? This is the goal. We're going to do that by using what's called the box method to organize our work. First, starts out like what we did yesterday. Find the factors of A times C, that also have a sum of B. So they have to multiply to give you A times C, and they have to add to give you B. This should look familiar. Then you're going to draw a 2x2 box, and you're going a grid, and you're going to fill it in like this. This is how you fill it in. Ax squared goes here. The 2 factors go here in the diagonal, and C goes here. Then you pull the GCF. GCF should look familiar. We practiced that on Monday. You pull the GCF, I don't know if you can tell the arrows, to the left, and then what's left over goes up on top. Now you might be like, what is she talking about? I'll show you in a second. And that's it. Then you'll see your factors. Your factors will then be here and here. Those will be your answers. Okay? So let me show you. All right, here we go. Example. And by the way, I'm going to do one example, and if you get it, take off. Take off with it, because it's the same every time. Nothing changes. Okay? First part, A times C. Come over here. This should look like the same thing from yesterday. 5x squared times 6. 5 times 6 is 30. I need it to add up to negative 13. Think of the factors of 30 that can somehow combine to give you negative 13. Take a second, try it. Try it. There's actually 2 possible answers, but when you throw the signs in there is when you'll be able to say, never mind, there's only one right answer. Why am I saying there's 2 possible answers? What are they?
15 times 2.
15 and 2, or 3 and 10. So there's 2 possible answers, but now it's a sign game, right? So it's got to multiply to give me positive, which means These are both positive or these are both negative. Then it's got to give me a negative. Well, that's your clue. Then these both must be what? Negative. So make them all negative, and now double check which one works.
3 and 10.
The -3, -10. You see that? The sign gain changes it. Like you might be like, oh, there's multiple right answers. Yeah, until you look at the signs. Now there's only one right answer. All right. So we got -3 and -10. So that's from yesterday. Here's the new part. Just watch and then copy it when we're done. And then that way you've watched the whole thing. The box is just to help you organize your thoughts, because the people that do math like all over the place are going to struggle with factoring. So the box method is like, you know what, let me help you. We're going to just put everything in its place, and then that way you can actually see the math unfold, and then you can see your answer. And then as I walk around, because everyone has the same box, I can be like, yep, yep, yep. So that's the whole reason behind the box method, okay? It's just to help you organize your thoughts. So remember how to fill it in. Ax squared goes in the top left corner. Ax squared is your leading term. So 5x squared goes there. Just watch, y'all. Just watch. You can write it in a second. C goes in the bottom right corner. So +6 goes here. Then the two numbers that you just came up with, right, they go in the diagonal. Now, we need to throw an X in there next to them, okay, and you'll see why in a second. And it does not matter what order you put them in. You can do -3x here, or you can do -10x. It doesn't matter. That's the beauty of this whole process, is you and your neighbor can have those switched, but you'll still come to the right answer, okay? Now, I have everything organized. I have just taken a trinomial and I have rewritten it into a 4-term polynomial, because -3x minus 10x is -13x. Do you see that? So this is really the same polynomial. Now, here comes the GCF part. Focus your attention right here. Focus your attention there. What's the GCF between 5x squared and -10x? 5. First of all, it's not negative because the leading term's not negative, okay?
It's 5x.
It is 5x. It's not squared. This is x to the first power. It's always the smallest number or smaller and the smallest exponent. Y'all with me? You can't pull more than that's actually there. So it's 5x. So you're going to write it. Oh my. Somebody saying. Yeah, I know. All right. You're going to write it right here. You're saying, hey, that's the GCF of these two. Now watch. Don't write yet, y'all. Just listen. Now, what's the GCF here? Leading term is negative. Leading term. Let's just say the first term here is negative. So you need to pull the negative. So it'd be -3. Yeah. Because -3 will go into 6. It's always the smallest number or smaller. Okay? Always check if the number itself will work. Now, why can I not pull an X out? Because there's no X on the 6. There will never be an X on the constant. If there is, you missed an initial GCF that you should have pulled out, which is okay. I'll show you how to handle that if that happens. So the GCF here is -3. Now, here's the fun part. Here's where you say to yourself, what's left over if I pull that out? So watch this. Watch my fingers. 5x times what gives me 5x squared? X. Repeat. 5x times what gives me -10x? Negative, oh, my sleeve's touching me going football, whatever. -2. Double check. Watch this. Is -3 times x -3x?
Yeah.
Yes. Is negative 3 times negative 2 6? Yes. So then you did it correct. So now, watch this. This trinomial has now just factored to 5x minus 3 times x minus 2. And we're done. And we're done. Now, I'm going to give you a second to write all that down, and then I want to work number 1 with you. I'm going to show you a step that you can omit and have less to write, but still do the exact same thing. Take notes. Get that down, and then I'll show you how to do it. Should be writing all of that. There we go. Hey, it's a teachable moment. Do we make mistakes in math?
Yes.
Yeah. all the
Why do you
time.
need a pencil?
That's why you need a pencil. I think I fixed it. Back to the. Okay. All right. Here we go. Let's draw our x and do what we did yesterday. A times c is 12 and b is negative 8. And what numbers do you come up with? Still negative 2, negative 6. The part I had messed up on was the top left corner.
Is it always going to be x and 2?
X and 2.
Yeah.
What do you mean?
See how? Miss Holcombe?
No, it's not always x and 2. No. That's coincidence. But hey, it is always this, by the way. It is always this top left corner is surrounded by GCFs with x. And then these two should be numbers. If you remembered to pull any initial GCF out. All right. We drew our x and we came up with our numbers. Now we're going to fill in the box. Remember, talking to myself here. Remember, the first box is ax squared, leading term. The last box is c. So this is 3x squared, and this is positive 4. Thank you. You get a tiger book for having the courage to be like, you're wrong. I think you might be wrong.
I would have told you that you're wrong.
But actually, thank you for handling it the way you did too, because it really like burns my biscuits when people are like, "Good grief, you just how could you get that wrong?" You know what I mean? I'm working on 4 hours of sleep. Now we're gonna fill in our numbers. It's the 2 that you just came up with. Don't forget to put an X with them. It does not matter how you fill them in, guys. Doesn't matter at all. Watch your name. Now yours would be different than mine in terms of GCF, but then the final answer would be the same. Basically, the 2 binomials would switch if you had switched those. You know what I mean? Like this binomial would end up over here, and then that one would end up over there if you had these the other way. But you still get the same answer. All right, here we go. GCF time. GCF of these 2, write it to the left. GCF of these 2, write it to the left. And then let's check and see if we got the same thing. Write the GCF to the left of each row. What's the GCF of 3x squared minus 6x? 3x. By the way, the sign here is always going to match that GCF sign. What's the GCF of negative 2x plus 4? and always pull the sign in the front, okay? So -2. Now, how do you get the top? You ask yourself what's left, or you can say to yourself, this 3S, the GCF, times what would give me what's in the, I guess you could say the cross section, okay? So 3x times what gives me 3x squared? 1x. 3x times what gives me -6x? -2. And now the last one serves as a checkpoint. -2 times x is -2x. Good. -2 times -2 is 4. So my answer is 3x minus 2 and x minus 2. Logan, I see now why you said, is x minus 2 always the answer? Definitely not. That's just coincidence. Now, I have a question. What if someone wrote it this way? X minus 2 times 3x minus 2. What if you wrote it that way?
Isn't it so right?
Is this what?
Isn't it so right?
Yes. Do you remember learning that multiplication is commutative?
Yeah.
Meaning it doesn't matter how you multiply. So like 3 times 4 is the same thing as 4 times 3. So even if you wrote it in the other order, it's still correct. Which is why the whole arrangement of your two numbers on the diagonal doesn't matter, because you're still going to come to the same answer. All right. That's two problems you've now seen worked. I hope it's, maybe you're starting to realize, like, okay, it's not so bad. Maybe not if I'll do it right the first time. Go to number 2. Number 2. 4 times -25 is what, y'all? -100. And then B is -15.
-40 minus 5.
Hold on, I don't like how my X is drawn. Wait a minute. -100 and -15. There we go. So remember, the number in the top is A times C, and the number in the bottom is just B. All right, what factors of 100 can somehow give me 15? 10 and 5? So this is, don't look at anyone like they're crazy, please. This is the process. 10 and 5, right? Is that going to somehow give me 100 when I multiply?
No.
So remember, you're working with the numbers that multiply to give you 100. 20 and 5 works. Now it's a sign game. So 20 and 5. Now we got to figure out our signs. Remember yesterday we said that the sign at the bottom is the sign of the bigger number every time. So the bottom number is negative, so I'm going to go ahead and make the 20 negative. Then I can ask myself, does the 5 need to be negative or not? So let's check it. 5 times -20 is -100. Run your eyes across. 5 minus 20 is -15. So these are correct. Okay? With me? Yes. What? Do you have this done? Yeah. Get this done and then you can go. If you don't mind. I mean, you got a pencil at 8:48, so a little aggravated. All right, well, let's fill in the box. Top left is AX squared. I'm never going to live that down, y'all. I'm going to text my math friends and be like, you're not going to believe this. I totally taught it wrong on this second example.
Your math friends.
My math friends.
You have math friends?
Yes!
Like, you join like group chat with like math?
You
You guys like talk about math?
Yeah.
Do you just like join group chats with like random math teachers?
No.
You don't
No. We share resources or funny stories.
Tell us a funny story. Are you like in
I
a
will
math
one day.
group? Like you know like a book group?
I
where you
just
go-
applied for my to get into the doctorate program. So I'm in
You're
like.
gonna be Dr. Holcombe.
Yeah.
Doctor.
Yeah, but I don't think I want to be called Dr. Holcombe. It just doesn't.
Okay, wait,
it doesn't
these are
ring.
masters?
I already have my master's
Then
in
why don't
math.
people call you Master Holcombe?
That's my
Yo.
husband said the same
Hey,
thing.
doctor.
He said
Master.
master sounds more studious than a specialist. I have my specialist. I just finished it this summer.
I'm gonna call you Master Holcombe.
Specialist is an additional degree after
Specialist
master.
Holcombe. That one
My
doesn't have a
master's is
degree.
in just math, which is very hard. And I was like one of the only girls in there because you don't see a lot of girls in math.
Girl
Master
power,
Holcombe.
It
Master
is.
Holcombe.
But I
That's
think
how we
when I get my
define
doctorate, y'all hear me out. What do you think? I think I'm gonna go by Dr. J.
Oh,
Where did Jay come from?
J's my first name.
Oh.
And you
I
know,
thought your name was
one
Ashley.
of- Jay Ashley. One of my favorite rappers from the 90s was Dr. Dre. So I want to be Dr. J.
I like it.
That's what I hate.
I
You
like
like
it.
it?
Yeah.
I
Yeah.
like Holcombe. Yeah, but
Why are you playing with yourself?
well, we're not gonna be here.
Yes,
students.
listen,
Yeah,
yeah,
y'all won't. Well, you're freshmen.
Hey,
You,
Doc.
I could have it before you graduate from high school.
Yeah.
And I'd be come out and say, "Hey, Dr. J." And I'd be like, Mr.
I just love Dr. J better than Dr.
Master
Holcombe.
Holcombe.
Yeah.
Dr.
Dr.
Holcombe
Holcombe
sounds
doesn't
like
have a ring.
My favorite is Master Holcombe.
I don't picture
Master
me
Holcombe.
when I hear Dr. Holcombe. That just sounds like a podiatrist.
We call you Master Holcombe for now, and then in
Yeah,
4
we'll call you
years,
Master Holcombe, and then when we graduate, I would say, "Hey, Dr. J."
There you go.
boom.
All right. I digress. He's not focused on algebra 1. So,
Actually, you can call me like
let's
this.
move on.
It's
Let's
finished.
move on. Your two numbers that you just found go in the diagonal. Don't forget to put an X with them. If you forget the X, it totally messes up the system, okay? Remember, it does not matter how you fill it in. So this is 5X and this is negative 20X. Now we're pulling the GCF. Pull the GCF to the left and write it for each. And then I want you to go ahead and write what would be left at the top. And let's see if you get it right. All right, so you ask yourself, this
We're going back to
times
the old
what
days.
would give
The
you
time
4x
set back with
squared?
the clock set back.
X.
Time set back 100
Hey,
years.
something's wrong. You forgot the X on this one. And then that means this would actually be 4X. You see how now they have an X on it? Yeah, so this needs to be 4X. That GCF.
Good girl.
GCF should always have an X, and this should always be an X. Okay?
The track. Okay.
This should not have an
Oh, no,
X
this is
in
as high as
GCF
your
right
rose.
here.
I should try to make it really. Wait, no, like put it down.
This is right here. Well, and right here it should be an X. Okay?
Ready?
So they got 3 in common, and they have an X to the first power in common.
Master.
Okay?
I rose.
They both have an X. So that's it in GCF. Y'all, shh.
Sorry.
So this would be 4X.
Wait, wait.
Now ask yourself, 4X times what would give you 4X squared? Yes, so put an X there. And then say 4X times what would give you negative 20X? Yes, that goes there. Alright, this is not working. Alright, I'm gonna put the answer on the board. Here we go. GCF across the top. Across the top row, GCF. 4X. GCF across the bottom row, just 5. And you can put a positive there if you need to, but it's just 5. Now you gotta write what's left. You're dividing here, you're factoring, and you're writing what's left. If you're not good with dividing in your head, then ask yourself, this times what would give me that? So 4X times what would give me 4X squared? X. 4X times what would give me negative 20X? Negative 5. And then double check the bottom row. Does 5 times x give me 5x? Yes. Does 5 times negative 5 give me negative 25? Yes. Then you did it right. And you can write your answer. So you got 4x plus 5 and x minus 5. I'll be honest, it's very easy the more you do it. First couple of times it's challenging, it's a headache, but the good thing is nothing changes. Like this is it, this is how you factor a trinomial, a quadratic. Remember, these are quadratics. You're taking a quadratic, degree 2, and you're breaking it down into 2 binomials of degree 1. All right, everybody try number 3.
I've already done all.
So at this point, if you understand it, go ahead and take off with the questions. I'm going to walk through number 3. So it should be A times C. You got 36. B is 37.
Got it.
Now I need you to come up with the numbers on your own. What numbers could somehow combine and give me 37 that multiply to give me 36? Yep, 36 and 1.
I got it.
Now, notice the polynomial had all positive signs. That's your clue that your numbers are all positive. So that's good news. That makes less of a headache. You should be trying this, okay? Everyone should be working. Now we're ready to fill it in. Don't forget this box here is always ax squared, right? Don't make the mistake I made. And then the bottom right box is c. And then now we fill in the diagonal based on the 2 numbers you just came up with. But don't forget to put an x with them. Put the x with them. If you think you're going to forget the x, then over here, go ahead and start writing the x. You know what I mean? Go ahead and start writing the x, and then that way you won't forget the x. Now, do I need to write 1x? Nope, I need to write x. And then this is 36x. What's the GCF across the top?
6.
There's more. 6.
6x.
6x. Some people do better to go ahead and start the top, like filling in the top right here. 6x times what gives me 6x squared? X. 6x times what gives me 36x?
Plus.
Now across the bottom, what's the G? Are you killing me?
Oopsie doopsie.
Across, I'm kidding. Across the bottom, what's the GCF here?
I know y'all saw it.
I'm being aggressive. Oh, was it this one?
What's the GCF with x and 6? Hey, you have to have a pass. You have to show me.
Good.
He's going to snap back Hayden.
Can I pull a 6? Can I pull a 6 away from 1x?
No.
No. It's 1. Guys, I said it's the smallest number or smaller. Can't pull an x out? Gotta take your phone?
Yeah, I just told you he's going to snap back Hayden.
Ruh-roh.
Alright, so this would be 6x plus 1 times x plus 6. I'm running out of room.
Wild as king.
I know it's costing 30.
Please do number 4. Skipping to number 5. Looking at the numbers, when you multiply 8 times c here, you get a massive number, which is your clue. There might be an initial, like a premature GCF that you can pull to the front. Now, here's the problem. You have to keep it there, though. It doesn't just disappear. What number will divide into all 3 of these terms nicely? 4. Let's pull a 4 to the very front. Pull a 4 to the very front, just a 4. So that would leave me with 4x squared. What's 60 divided by 4, y'all? 15x. And then negative 100 divided by 4. Negative 25. Now I have a more manageable polynomial. Now you focus your attention on just this, and you do it like normal. When you write your final answer, you do need to bring that 4 down, okay? So your final answer will be 4 times the 2 binomials. But this is called, let's take the note, this is an initial GCF that made the problem smaller by pulling it out. The same thing's going to happen over here. What goes into 6, 4, and 16? 2. So there's an initial GCF of 2 here. And then now you can just focus your attention on that polynomial, okay? Your practice assignment is the back of this paper.